All right, 4.2. So more of the same, so linear functions. In 2002, a school population was 2428. By 2009, the population had grown to be 2981. How much did the population grow between the year 2002 and 2009? So what are we going to do to figure that out? So we're going to subtract the 2981 and the 2428. Somebody got a number there? 553. So the population grew by 553 students. Next question. How long did it take the population to do this? How long did it take in years? Yeah, because it's 2009, take away 2002. That was in 7 years. So their next question, what is the average population growth per year? So, if they want the average growth per year, right? So in other words, the population of the school went up 553 students. 553 students over 7 years, didn't it? So if we divide, we'll find the average number of students per year. Somebody get that number? 79. So it's like they were growing by 7, and then they want the units here. It's going to be students per, like over year. Oh no, I wrote per year. The per is the slash. Students per year. That's what they want in the bar there. It's 79 students per year. The population was going up 79 students every year. What was the population in the year 2000?
2,349.
How do we figure that out?
You take the number of students in 2020 and you subtract that 79 that you got per year.
So in the year 2002, there were 2428 students, right? So if we back up 1 year to 2001, what would we need to do? Minus the 79, because remember, we're saying it was going up 79 every year. Now we're assuming here, we don't really know it was doing exactly 79 every year, but we're just assuming that. We're saying, assume that the population was just always steadily growing the exact same amount every year. That's linear growth, straight line, no curvature at all. So if that's the case, that'd be 2001, and then we got to get all the way back to 2000, we got to subtract 79 twice, don't we?
Yeah.
So subtract 79 and then 79 again. So somebody got an answer there? 2270. 22, there'd have to be 2270 because we just back up 79 students twice. Next question. Find an equation for the population P of the school T years after 2000. T years after 2000. So how are we going to do this? The population. So remember what it always is. We're going to have something times t plus something. Remember these linear formulas? They're mx plus b, basically. So it's going to be mx plus b, mx plus b, but the t is the actor playing the role of the x. Let's say the t is time, same thing now. All right, so the slope, the m, is what's varying. It's what's next to the variable, the letter. It's what's changing year by year. So what's the change year by year? That's the 79. Every year it goes, is it positive 79 or negative? Is it going up or down by 79? It's going up. So it's positive 79. Does that make sense in a linear equation? the number next to the letter is the change. Positive is up, negative is down. We're going up 79 students every year. So plus 79 times t. Plus, and then what's the number at the back? Remember, that's always the starting number. That's the 2270, because that was how many in the year 2000. Because we're comparing to, we're saying after the year 2000. What did it start? In the year 2000. So there it is, 79t plus 2270. That'll give you a formula. Now they want us to use it. Using your equation, predict the population in 2014. So how can we use that little handy formula to predict the population in the year 2014? What am I going to do? Going to plug in. What number am I going to plug in? 14.
To the P or the T?
Just the 14. For T, it's time. So not 2014, but 14. Why? Because remember what T is? Look up there at T. Read those words. They're telling you the whole secret right there. T is years after 2000. So if it's 2014, that's 14 years after 2000. So that just means we need to plug in T is 14. Time is 14 years after 2000. So plug it into that formula. So let's do it. We get 79 times T, 79 times the 14, plus 2270. Somebody got that calculation? 3376. And there we go. So do you see the real life nature of that linear equation? 59 or 79 students per year, it's growing, and then we find it in 2000, and we have the variable part and the starting part. Same thing as the last section, right? 5. So the phone company, Nextel, has a monthly cellular plan where a customer pays a flat monthly fee and then a certain amount of money per minute used on the phone. If a customer uses 480 minutes, the monthly cost will be $181. If the customer uses 600 minutes, the monthly cost will be $217. Find an equation in the form of y equals mx plus b, where x is the number of minutes, y is the monthly. Nextel is a total monthly plan. So, in other words, it's exactly what we were doing before. So we're going to basically look at these numbers and go, 480, that's x1, 181, that's y1. 600, that's x2, 217, that's y2. See how they're just giving us an x1, y1, x2, y2. We do the exact same thing that we did in all the others. Let's crank it out again. So step 1, find the slope. How do we find the slope? We use all 4 numbers, right? y2 minus y1. y2 minus y1 over x2 minus x1. So the slope is going to be y2. Where's y2? Here it is. 217 minus 181. y1, 181. Over x2, 600. Minus x1, 480. Is that 19? Is that 36? Over 120? And now we can reduce that fraction. Divide top and bottom by 12. Would be one of the easiest ways to go. Divide top and bottom by 12. You'll get 3 over 10. So we reduce that. So there's the slope reduced. All right. Oh, you know what? They probably just want a decimal. Yeah. Just make it a decimal. Just make it 0.3. That's just 0.3, right, on your calculator? Just divide those. I think they'll just take a decimal here. And then step 2. Step 2, they're going to say, okay, now we use the slope formula again, remember? With the y minus and the x minus with the blanks at the back. And we just plug the slope in the left side. And what do we put behind the y and behind the x where the blanks are? We just grab the x1 and the y1. Or you could do the second, the x2 and the y2. It doesn't matter. And plug them in. So the 480 is the x, has to go behind x. And the 181 is the y, has to go behind the y. So we get slope, which is 480. No, that's not slope. I'm getting confused. Slope, which is 0.3. And what goes behind the y value is the 181, and the x value is the 480. What do we do next? Cross multiply. Put that 0.3 over 1. Diagonal, diagonal. Bring it up here. We get 0.3 times x minus 480 is 1 times y minus 181. Like that. And then we distribute. So boom, boom. So I'm going to get 0.3x. So what's 0.3 times 480?
144.
Thank you. 144, and then 1 times y minus 18, which is y minus 18. Last step to get y alone. Y's saying what he's always saying, I want to be alone. And so we get 0.3x plus 37? 37 equals y. So there's the formula. 0.3x plus 37. So there we go. So do you realize what that means? What's the fixed cost? Like what's the amount they charge even if you don't use any minutes at all? That's the 37. That's the fixed cost, huh? And then the 0.3, that's not 3 cents, but 30 cents. It's really 0.30, right? It's 30 cents a minute. That's an expensive plan. $37 flat rate plus 30 cents a minute. That's international rates or something there. Anyway, and then last question, part of the question. Answer, 614 minutes are used. What will be the cost? So what if you talk on the phone for 614 minutes? You're going to wish you didn't. You're going to pay a lot of money for that, right? I got to use the formula. I'm going to use this formula. 0.3x, we're coming up to here. 0.3x plus 37, and I'm going to plug in 614 minutes. And then use your calculator. What does that come out to be?
221.2.
221.2? Yeah, no commas, but yeah, still use the decimal though. Yeah, no commas. It just says no commas, but it does want the decimal. So 221.2. 1991, the moose population in the park was measured to be 3290 by 1998. Population was measured again to be 2730. As the population continues to change linearly, straight line, right? Find a formula for the moose population in terms of T, the years since 1990. It's the same thing again, isn't it? But let's be a little careful. It's really the same thing again. But let's make sure we honor that last phrase, years since 1990. So in other words, we're going to go up and we're going to do the same thing we've been doing. We're going to say X1, Y1, X2, Y2, like usual, right? And then we're going to have our, all the rest. But hold on. It's not quite the story. X1 isn't supposed to be 1991. Why? Because they said years since 1990. So if it's 1991, right now, it's not, obviously. But if it was 1991, how many years since 1990 would that be? That'd be 1. So they really want X1 to be 1, not 1991, but 1. Because it says right here, always have time be years after 1990. So what would X2 be in 1998? Just 8, huh? Does that make sense? So the rest is the same. I'll do like the first step and go dot, dot, dot. Do you see what we're doing there? So when they give you a phrase like that, and they say, hey, and they're going to do that a lot. That's really common, especially in science problems. When they use this kind of stuff, they do a lot to biology and chemistry and physics. They will pick a starting time, like 1990, and they'll say, let your variable x be years after 1990. So be careful to change x. So 1991 becomes 1, because that's 1 year after 90, and 98 becomes 8, because that's 8 years after. So otherwise, you just do the same thing. You just go, okay, I know how to do this. Step 1, slope equals y2 minus y1 over x2 minus x1. So that's going to be y2. Where's y2? Here it is. 2730. I'm going to bring it down, I guess. 2730 minus y1, 3290, over x2, which is 8, minus x1, which is 1. And then, does that come out clean, or? Is it 560 over 7? Negative, negative 560 over 7, which is negative 80, huh? Comes out negative 80, and then you know step 2, right? We write the slope formula again. I'll put it over here. Write the slope formula again. Y minus blank over x minus blank. I'm kind of doing these backwards here. Step 1 on the right, step 2 on the left. And so now, what are we going to plug in for the slope on the left? That negative 80 number. Right there, negative 80 equals y minus blank over x minus blank. And what goes in the back of the y? y1, 3290. Right there. And what goes in the back of the x? 1, huh? Right, like usual. Can I go dot, dot, dot? Right, just put the minus 80 over 1, cross multiply, get y alone, and you've got it. But they want you to use t, though, when you get your final answer there. So make sure you do what they want. They want the final answer in terms of t. So, I could, let's see, minus 80 over 1 here. Let me do that. And it was a y minus 3290 or x minus 1. Yeah, so we would cross multiply minus 80 times x minus 1, y minus 3290 times 1, distribute, boom, boom, minus 80x plus 80, distribute, y minus 3290. Y saying, I want to be alone. Add the 3290. And then, thank you. So there it is. But when you write the answer, they don't want that x. They want a t. That's what I'm saying. They want you to put a t. So if you look back to the question, they put t in the parentheses. So it's the actor thing again, right? T is just the actor playing the role of x. So minus 80t plus 3370. So right here, minus 80t plus 3370. You got to get rid of the x because they said p, population at a time, t. So it's the same thing as x. It's just the actor playing the role of x. You can do part B. What's the moose population going to be in the year 2008? So what would we do?
Or just add 8?
Plug in for t, 8. That's saying t is 8, huh? Right? Because remember, time is years after 2000, so 2008 is 8. Plug that in for time.
It's 1990.
Oh, I didn't notice. Thank you, guys. 1990. So how many years is that after 1990? 18. Thank you. I'm being a little too hasty. So that's going to be minus 80 times 18 plus 3370. Somebody got an answer there?
1930.
1930 moose. I don't know what the plural is for moose. I don't think it's mice. So, mooses. Yeah, good. So you had to plug in 18 there because the year 2008 is 18 years after 1990. Thanks. I forgot 1990 was our starting point. Good. All right. Let's go on to number 4. Suppose that the world's current oil reserves, how many barrels? If on average the total reserve is decreasing by 18 billion barrels of oil each year, answer the following. Write an equation. R in terms of T. So they want me to do R in terms of T. And so what's it going to be? R equals, so remember we're going to have mx plus b, basically. That's what everything linear is. It's always mx plus b. So what's the m going to be there? Remember, m is the slope, it's the change. What's the change year by year? It's decreasing 18. So is that positive 18 or negative 18? So that's negative 18x. And what's the b? That's the 1970. Because that's how many barrels we have now. That's the start, huh? So we always have the change and then the start. So there's the formula. Does that make sense? So whatever's next to the variable is what's varying, what's changing, right? It's the slope. And whatever the other number is the start. So that's the start. That's the change. Okay, and you can answer the other questions, right? 8 years from now, what would you do with the 8 years from now? Just plug in 8 for x, huh? And then question C, if no other oil is deposited, let's do that one. When would it be completely depleted? Yeah, let's do question C. How would we figure that out? So what are we going to do for that? So question C, we know B is just plug in 8. But C, how can we use that formula to predict when all the oil's gone? Beautiful. Jaylene, yes. You make the R 0, and you solve for the X or the T. So I mean, they're saying, when are the reserves going to be 0? Does that make sense? So rather than plugging in X, we're plugging in R. Because when it's all gone, depleted means plug in R is 0. The reserves is 0. So we're going to take the equation. R equals minus 18x plus 1970. And we're going to take 0 and we're going to plug it in right there. 0 is minus 18x plus 1970. Does that make sense? They're saying, when's the reserve going to be 0? When's the reserve going to be 0? Whereas on part B, they asked us 8 years from now. So we plugged in x is 8. So now we need to solve that equation. Let me bring it over here where we have a little bit of room. We need to solve that equation for x. What do I do to x and say, I won't be alone?
Minus 1970.
Beautiful. You guys are getting to be used to these, doing a lot of these, huh? minus the 1970. So that'll be minus 9, if you can see my writing there. Last step to get x alone? Divide by negative 18. Somebody have that on the calculator? 109.74? 109.44. They want us to round your answer to this. Well, there it is. So 109. So 109.44 years from now, the oil's all gone. If that formula is really predicting things and they continue to change in that linear fashion. Is that good? So at 12 p.m., the volume of water in a tank started changing steadily over time. The volume V, measured in gallons, T minutes after the water volume started to change, that equation. The equation tells us that the volume of water was initially, so looking at that equation, which number tells you what it was initially, which means at the start, huh?
3,600.
Yeah, the number that's not next to the letter. Remember, the one next to the letter is the one that's changing, varying. It's next to the variable. Yeah, so this is the one that's at the start. And the one next to the letter is how it's changing every hour. Is it hour, minute? This is T is in minutes. This is so every minute, right? So the start is 36,100. And that the volume is, they're going to want you to say increasing or decreasing. Is the volume going up or down? Is the change positive or negative? Yeah, decreasing. It's going down because it's negative, huh? And by how much? By 18.05. They don't want us to put the negative sign in. The word decreasing is kind of like being the negative. And then they're probably going to want units there. So I'll say the units on that. Did they say what the units were? Oh, gallons. Gallons per what? Minute. Because the T was in minutes on that one. Good. How about number 6? The function shown in the table is linear. Find the slope, y-intercept, blah, blah, blah. Yeah, how can we look at a table and find a slope? We kind of did that earlier, huh? Remember? Slope is like y2 minus y1. Let me move it down a little bit here. Slope is y2 minus y1 over x2 minus x1, isn't it? So you just basically need to grab any 2 points you want. Like I'm going to grab this one because it's 0, and 0 is a nice easy number. That'll be x1, x2, and this will be y1, y2. You could grab any 2. It doesn't matter which 2. It'll work out the same. Just grabbing the 2 that look easiest to me. You got to grab ones that go together, right? This x and y go together, x1, y1. And this x and y go together, x2, y2. And then calculate the slope. So y2, it's minus 28 minus 2 over 5 minus 0 minus 30 over 5 minus 6. Minus 6. So that's the slope. They're wanting me to kind of come up with the y equals mx plus b. So we've got the m, and now we need the b. What do you think the b is? Remember, the b is always where it starts. Remember that? The b is always the start. Now, careful. Start means whatever's next to x0. It's going to be the 2. That's what we mean by start. We mean if you plugged in x0, what would y equal, right? If x is 0, if you plug in 0 there, see how the x part will vanish and y will just be 2? Everybody see that? When you plug in 0 right there for x, y, the minus 6x would just vanish because minus 6 times 0 is just 0. Y would just equal 2. So the b is the number Next, it's the y, that b is the y value. Y value next to x is 0. It's the starting value right next to x is 0. So there's the equation. The y-intercept is 2, and there's the equation they want on the third part. Question 7. Some values of a linear equation are provided. Complete the table. Okay. So they started to give us some values. How could we find the rest of the values? It's linear. So linear means it always goes up by the same amount. So how much did it go up by from there to there? What was the jump from -2 to +2? That went up 4, didn't it? So then just do that again. Go up 4 again. What's it going to be? 6. And do that again. 10. And do it again. Makes sense? That's what it means to be linear. It just always goes up by the same amount. Good. Let's see, where are we at? Number 8. Which of the following equations work for that graph? Yeah, good question. Which of those is really right? Yeah. Okay. So what would be the easiest way of figuring that out? I'm thinking probably let's take the first equation. Bring it up here. And 3x minus 3y is 36. And yeah, they're saying the intercept. Yeah, let's do that, huh? So yeah, so what are those? Just like, what is this point right here? What's his coordinates? Got to be careful not to mix up the order. The order is real important. What's the order there?
0,
Good. That's 0, negative, because remember, it's x first, then y, right? That's over 0, down 12. So plug that in. Try that. Try putting in 0 here and negative 12 there, and see if that works for that equation. See if it makes it true or false. Does that make it true? 3 times 0 would be 0. Minus 3 times minus 12, is that plus 36? Yeah. Yes, that's true. That's 36 equals 36, huh? Okay, but what about the other point? There's a second point. There's this one. What's the coordinates of that point? It's got to make them both true. What's the coordinates of that point? 12, 0, right? Over 12, up 0. So now take the same. We're still wondering if this first one is the answer. So take the same equation again, and now try plugging in. It's got to make, the real equation's got to make both those points true. Plug in 12 for x and 0 for y and see if it's true. 3 times 12 minus 3 times 0, is it 36? Yes. That's the answer. It made them both true. If you tried the other equations, it wouldn't work. Like, let me just share. If you grabbed this one, minus 3x minus 3y is 36, and you plugged in this 12, 0, plugged in 12 for x and 0 for y, that would be minus 36 equals 36. No, it wouldn't work, for example. So that's how we know what the real answer is there.